Hi everyone, my name's John Fletcher. I work for a company called The Innovation Game, which I'm a founder of. My background is I have a PhD in maths and theoretical physics from Cambridge University, and I looked at the problem of scattering of light from fractal objects and how to estimate the fractal dimensions. So it's sort of maths with a little bit of physics. So that's my background. Lots of computation algorithms. I mean, this is how I got into applied maths and specifically algorithm development, which at that time was dominated by human beings. But I'm here to talk about the economics of algorithm development, AI-assisted algorithm development. Really one of the reasons is when I started thinking about it. Of course, the first instinct when you have an AI that can now develop algorithms, it's sort of off to the races. See what you can do and make them better. There are sort of higher level concerns to do with the way that it fundamentally changes the economics of research, which I'll talk about a little bit. And it is a sort of cut a long story short. It seems to push it closed. So there is a bit of a precedent for people, taking a bit of a kind of diversion. To do something a little bit higher level. I don't know if you guys know that Richard Stallman, who invented copyleft and came up with the GPL license, which really kind of was foundational to the early days of open source, was in fact a sort of an AI researcher at MIT. So using copyright, which is of course a property right to keep things open rather than closed, doesn't really sound like the kind of thing that a mathematician or an AI researcher would do. But of course, for him it was really worthwhile as a means to an end. So that's kind of like the spirit of this thing. So I was going to show a quick video about talking about how important algorithms are, but I think now that Stephen's given the talk, it's not really much point. But for long story short, the guy who's the head of the top hardware company in the world is basically sitting there and saying that algorithms are a lot more important than hardware. When Jensen says that, you probably know that it's true.
The only way to really
there's no reason to hear him tell what we already know. So as I quickly mentioned before, AI-assisted algorithm development it changes a lot of things, of course. But one of the things it changes is it changes the economics of research and research into algorithms. So discovering algorithms now with AI is open to anybody with a computer. One of the things is in a sense it kind of lowers the barrier to entry. I think there's reason to believe that more people could meaningfully contribute to certain areas of mathematics, because they had sort of skill with AI or skill with the computer than was the case before. So in that case, it's a sort of a force for democratizing this. But unfortunately, the things that come out, the better algorithms, are not necessarily able to be sort of monetized to the same extent, independent of who you are. And you might think that, well, that doesn't really sound very much like kind of research or monetization. Who cares about that? The problem is that this type of research requires money. I mean, if you want to be able to run large numbers of computers, they don't run on sort of goodwill or kudos or anything. That they run on, you have to pay for them with dollars or pounds. And so if you can't capture the value, or you have a sort of diminished ability to capture the value of the thing which you're generating, which is a better algorithm in this case, then there's a sort of uneven playing field. And if certain people can monetize algorithms more effectively, then it just means that they tend to sort of get ahead, and the whole loop of economics and capitalism sort of runs faster for them than it does for other people. But the first one really is just a technical fact, which of course is naturally what the mathematicians focused on. But the second of these is really just an issue of market design. It's a market design problem, and it's solvable, and that's what I'm going to talk about today. And if market design rings any bells, you might have heard of this guy. If anybody wants to know what a market failure is, I recommend his book. This guy's Paul Milgrom, who's a famous economist, Nobel laureate, in fact, who works at Stanford University. And the work is in some way inspired by his work, but I won't talk about that now because it's if you're interested why, you can ask me later. So just quickly, in talking about how algorithms were often open, historically, Stephen said, of course, some algorithms like maybe the state-of-the-art optimization or convex optimization problem are closed. I think that the reason for that really is they do have a kind of more direct commercial applications and route to monetization. If you think about, we're quite lucky to know how, the transformer work that was published openly, and know what the state-of-the-art optimizer is, something in the sort of Atom optimizer family. People generally know how that works. So these were sort of published openly, and this is kind of the norm for a lot of algorithms. One of the reasons, sort of historically, was interestingly the sort of very kind of sporadic progress in algorithms. So you had like a very large jumps. I think kind of maybe even decades of not much going on until you have a sort of very very big improvement in what the state of the art in a certain algorithm field is. And this sort of wiggly line, you're not going to be able to see it, is Moore's law, how quickly hardware improves. So in fact, there's this interesting paper, if you want to look at it up how fast do algorithms improve. What it tells us is even sort of historically, in the kind of era of Moore's law, algorithms were in fact, in aggregate, even more impactful from in terms of, speed up effective compute than hardware speed ups. But of course, it's a lot less predictable. And this is really why it wasn't typically privately investable. Because it isn't to say that it isn't investable. I mean, governments invest in it. That's the reason why they fund research, because they have special ways of capturing value, which is that the people often, start businesses around these new discoveries and then they tax them. But private, it's not so, hasn't been historically so attractive for private capital. That has downsides, but one of the notable upsides was if you get public funding for your research and it won't be done otherwise, typically you're going to publish the results openly. People don't think that public funding should be used for people just like inventing things and then keeping them proprietary to themselves. So it tended to mean that the algorithms were published openly, but this is changing now because algorithm development, because of AI, is becoming privately investable. But as I'll explain, it's sort of more privately investable for some people than it is for others, which is a little bit potentially centralizing. So here, I can go through this sort of quickly. So this is really about what will pressurize companies. And let's take sort of Google as the sort of classic example, because they're probably the furthest ahead in this area with AlphaEvolve. So there's various sort of advantages they have. So that the advantages can compound if they keep the algorithms private rather than sort of publish them openly, which they are doing this with various algorithms already. So one, probably the most obvious one, is what I call the compute loop. So if you, invent a better algorithm that can be used to, let's say, run your data center more efficiently. Of course, the next day maybe you could deploy that to your data center and your costs go down by, a few $1 million a month. And assuming that your sales remain the same, of course, you've suddenly become a lot more profitable. So this is a very sort of easy, low friction way to monetize something that you've come up with, maybe by running AlphaEvolve overnight. And with that money, of course, maybe you can buy more GPUs, you can hire more researchers and so on. And then, you're even better at algorithm development after that. So it's a bit of a sort of feedback, and it's almost the most obvious one. So but of course, in contrast, if some, guy who's, just working on his own or in a small company invents this algorithm, he can't monetize it through his own massive data center because he doesn't have one. So in that case, you've got the issue, how do I monetize it now? I won't go into detail, but it's not very easy to monetize algorithms. One way that you can sort of tell this is a lot of people say in academia, if they invent one, they don't even tend to patent it. Like it's sort of, it's quite hard to sort of enforce patents. And obviously patent requires disclosure as well. So, but he can't keep it secret as a trade secret and monetize it. He could patent it, but they're hard to defend in court for various reasons, which I won't go into. So the takeaway from that is it's very much easier for some big entities to get a lot of value out of these things than others. And if you think about that, it might seem kind of obvious, but it's a bit weird. Like, if you're like a giant mining company like Rio Tinto or something, like obviously you've got economies of scale compared to some guy who wants to start up a small mining company. But if you manage to dig a kilogram out of gold out of the ground, is it worth about as much to you as it is to Rio Tinto? Right? There's a liquid market for these things. With algorithms, that's not the case. So there's very kind of subjective as to how easy it is to monetize them. The next one's got a starting point effect. And again, this is almost obvious. Like if you're running AlphaEvolve or some kind of agent, if you have a better algorithm and you keep it private, then the sort of you're working on a higher state of the art, right? So again, that's can have a compounding effect. Data loop, they're already doing this with some algorithms. There's one, I think, algorithm for optimally packing sort of those giant container ships. So Google came up with this. They offer it over API. Nobody really knows how it works. and apparently can make these ships sort of 40% more profitable, or the container companies. Sounds pretty significant. We have no reason to doubt that. But of course, people are using it, and that means they're getting all the data with the container ships, and of course that could have a compounding effect. They have more real-world data, and that means that they can, use the algorithm or use that data to that's an advantage because they have more real-world instances to test, further developments on. Mathematical know-how loop. This is kind of an interesting one, which sounds a little bit esoteric, but a lot of these algorithm developers, they find that there's quite a lot of value add from human input. They can get stuck, and then you can give them some sort of strategic direction, or a human expert can. And it might be a little bit like the advice that a supervisor gives to their student, relatively small number of words, but you can sort of, course correct them, they're going in the wrong direction. Interestingly, that stuff tends not to be written down. You can probably see in, the textbooks and the papers contain sort of mathematical proofs. They don't contain all the things which went wrong, which you didn't, or the kind of abandoned attempts. But that contains know-how. That's where people, mathematicians, build their intuition, and it was overwhelmingly sort of not codified. So that the LLMs don't have it in their training data already, but of course by multi-round interaction with a mathematics co-pilot or something, you're exposing know-how, which is basically strategies that you try when you get stuck to unstick yourself. And again, if one company gets this stuff, there can be a sort of data flywheel effect because it's captured through the interaction with the tool. Once your tool is significantly better than everybody else's, no one's ever going to use the second best one. And so it not only allows you to capture this very valuable data set, which is how to unstick the thing, it also denies it to your competitors permanently. And this is, famously, this happened with Google search, and a sort of, 25-year monopoly on search is one thing, but a monopoly on AI or mathematical, automated algorithm would be somewhat more, I think, sort of disconcerting, even than a web search monopoly. It's a lot of power for one country. And talent concentration as well. I think somebody said, they're employing a lot of mathematicians now. And the mathematicians want to be where the other mathematicians are. Maybe if you keep the state of the art private, naturally researchers want to be able to see the state of the art. They don't want to be working like, not on the cutting edge. And that could have a sort of compounding effect as well. Sort of best mathematicians drift into private, working for private companies, which is centralizing. So yeah, basically quite a few challenges here, and of course, like we're talking about, it's easy, we're interested in finding better algorithms and experimenting, but it's not sort of taken as a given that what we do, it depends what tools we've got access to, right? If we don't have access to AlphaEvolve, or we don't have access to these tools which are, the cutting edge ones, then maybe the only way that you could be competitive as a researcher, realistically, would be to go and work for Google and get access to the sort of more sort of private tools and proprietary stuff they have. Again, just to mention this point about the old mathematical know-how, I've been talking about this for a while, and I think it's kind of natural. People's reactions is, that sounds a bit odd. I haven't heard anyone else talking about it, so therefore it can't be very important. But we went to a talk by, this is the CTO of Google, Raghavan, on about 3 days ago, and we noticed in the bottom of his of note, failures do not go into the training data. So again, this is the thing that there's a lot of stuff that you need to make progress in mathematics, which is not necessarily codified, the strategies. And I asked him about it afterwards, and he was a bit like, had a kind of look on his face like, yeah, you're right, but I can't really talk more about it. I think I sort of inferred from that, they realise that it is very important. Capture of mathematical know-how. It's not written down anywhere, but they could capture it through the use of their tool. So, where are we with this? This was just to say that I wrote, if you want to know more about that, how important it is to capture mathematical know-how and the potential sort of data flywheel effect, data network effect that could have, I wrote an article about it on X. So again, I just wanted to check this thing. Like, it's hard to know how many people believe or have certain misconceptions, but just to sort of preempt this one, I do meet a surprising number of people who say, if you're worried about kind of open research or the best mathematical co-pilot being open source, don't worry, because the open community always finds a way to build something which is competitive eventually, and so on and so forth. This is not true. Sometimes it does, sometimes it doesn't. There's a sort of a lot of survivor bias. Like, people think that open source is mainly those consists of those projects which were successful open source projects. But of course, those were just the ones that worked. Google search, there was never a competitive open alternative to that. Again, it had a strong kind of centralizing network effect, the so-called data flywheel effect. So it just depends, right? You have to analyze the economics of it. Sometimes open source in its sort of vanilla form, in the traditional form of open source, will be a force to be reckoned with and a potential competitor, and sometimes it won't. It's just a case-by-case basis, and it just so happens that for AI-assisted algorithm discovery, unfortunately, it looks like it might have a strong, subject to various network effects, which will cause it to centralize. Oh, there's some activity at the moment. So the this is just so moving on to how we have tried to address this problem. So the problem statement itself, again, if you just take away that will be very useful, because a lot of people seem to be kind of somewhat peripherally aware, but not entirely aware that there might be an issue with the economics. Now that people can, develop very good algorithms through by use of AI, and this is a problem, and it's a real one. Of the first step towards solving the problem or doing something about it is to realise that it exists, and most people don't. But this is our sort of contribution. It's called the innovation game, sort of abbreviated by TIG there, and I'll just sort of quickly go into how it works. We have it's basically crowdsourcing better methods, better algorithms. And they can get rewarded, in this case, by tokens. The algorithms are tested, essentially benchmarked by people performing proof of work, for a reason I'll explain it in a moment. That they have the structure that they're sort of hard, these test instances are hard to solve and easy to verify, which is a necessary property of proof of work. And we put sort of various what we call challenges in there, non-convex optimization for neural network training. We're looking at energy grid optimization, knapsack problem, capacitated vehicle routing. Quite a lot of sort of quite fundamental sort of low-level algorithmic challenges. And it's sort of, you could think of it as a bit like Bitcoin, but like the miners can perform proof of work more efficiently with a better algorithm. So they tend to look at the algorithms the innovators submit. They adopt the ones that's solves the instances most efficiently for them, otherwise they'll be outcompeted. And we really just take that as a market signal as to which one to reward. We capture some IP embodied in the algorithms. Everything is sort of open source. The source code is available in Rust. The algorithms are implemented in Rust. Make it available under 2 licenses. So I don't know if anybody heard of dual licensing. It's sort of an old idea which kind of fell out of favour to some extent for an interesting reason, which we fixed. And the 2 licenses in our case, something called open data license, which is really like a share-alike sort of copyleft style license, but also has this data sharing obligation, which means that if you use the algorithm or an algorithm covered by the IP to process some data, and you sort of make a product out of the input, or even just distribute the input or the output or something derived from it, then you're obligated to make the input data available. So this is the kind of thing which will be sort of agreeable, or maybe even a matter of routine for, let's say, an academic researcher. Of course, you're supposed to publish the data that allows your results to be replicated. But for a commercial company, maybe not so much. So in that case, they might want to buy their way out of this data sharing obligation by paying for a so-called commercial license, which is really just a permissive license. So it's sort of dual licensing, or heavily inspired by that here. And then the commercial license fees, that causes the demand for the tokens, and that's the sort of how the demand loops into more rewards for the innovators and for the benchmarkers. So this is, I'm going through this quite quickly, but it's really, you can think of it as sort of dual licensing, but rather the way that the revenue from the dual licensing is rewarded is through a market mechanism. So that's the twist, which makes it really better than dual licensing and fixes the fundamental problem which it had. I'm not sure I'll go into this, but it's quite a cool video, so I'll play it anyway.
Oh, this is looking cool.
So again, this is a sort of what this network of benchmarkers is doing. Interestingly, is it's creating a market for something which there wasn't really the market for algorithms. There's a sort of strong source of demand for more efficient algorithms, but in their case, they just want to do proof of work more efficiently. But what that gives us is a kind of like a toy model of the real market for algorithms, but also one that's transparent, so we can see how much of each one people are using, which you can't necessarily see. And so what I kind of analogize this to is, you probably heard of analog computers. A wind tunnel is an analog computer. So you have some kind of scale model, and you sort of just read off what's happening, and it sort of gives you an idea of what would happen in the real race car situation. But this is sort of like an analog market. It's an analog of what the real market is, and you just look at it and you kind of read off. So this is helpful to understand why it is that the proof of work helps in this situation. Just again, a little bit of history. This was sort of anticipated. I guess the people who came up with dual licensing had read Eric Raymond's essay, The Magic Cauldron, then they might have known that there was it wouldn't have quite worked. Eric Raymond actually anticipated this. He said that he's kind of one of the founding fathers of open source. He wrote this very famous essay, Cathedral and Bazaar, 25 years ago. And he said, some things can't be done with a traditional open source method, specifically things which need monetary capture, generating a lot of value. So you should, in principle, you can capture some of that value, and some of that value can be sort of monetary in character. And but if you want to do that, he said, you have to find a market mechanism for distributing the value. He didn't really explain why, but it turned out, it seems to be true. And by the way, the reason why the dual licensing didn't really pan out is, some people think you can't get money into open source. It isn't true, because dual licensing proved that you could, but the money went to a sort of central vendor, and then they were responsible for redistributing it. And of course, you want to distribute it to the people who create the value, which is the community, the open source contributors. But there's an interesting thing that happens when you introduce money into open source. It's no longer, we're all working for free, we're all in this together. Now it's like, this guy got twice as much for his contribution as me, but why? Some guy at the top decided. And there's an interesting social effect whereby if a guy decides, you can get some kind of perception of injustice, and people became slightly disaffected, and it sort of kind of messed up their community cohesion to some extent. So one of the interesting things about markets is the so-called impersonal allocation mechanism. So it's not really anyone's fault or anyone's decision where it goes, and so it tends to. Hayek pointed this out, in fact, in the 1940s. It's more like a kind of law of nature. It's just a thing. Like if a tree falls on your house but it doesn't fall on your neighbor's house, strangely enough, that's less likely to result in a civil war than if some guy intentionally demolishes your house rather than the guy next door, because it's a sort of, there's someone to blame. Anyway, sociology, but it turns out to be very important. Again, going back to the innovation game here, I'm not sure the best. And so this is just, again, this non-convex optimization, optimizer for neural network training. It's one of our many challenges. I won't go into what all of these things mean, but this is a visualization of what the innovation game is doing, and people are submitting better optimizers, and we're kind of testing them, and they get rewarded if they're widely adopted by the benchmarkers who are performing proof of work. And I just wanted to go into this a little bit. So some of you might have seen Andrej Karpathy's relatively recent interview at the No Priors. He described something which was very, very similar to what we built, which was really amazing to hear. You might recognize it. It looks a bit like a blockchain. You're doing proof of work is basically experimentation, testing whether the things work, which is exactly what we did in the innovation game. Very cheap to verify candidate solution. Again, it's hard to find these things, better algorithms, but it's cheap to sort of verify. Hard to solve, easy to verify when you're trying to test the algorithms is the kind of asymmetric structure that you require for proof of work. Again, if you said a bit of an analog to setting at home or folding at home. In his vision, this was true, but those things are voluntary. In our case, there is monetary sort of remuneration, which in fact I think is necessary to really compete with the big tech companies at scale. You've probably seen they're building these Stargate data centers, which are sort of as big as 60 football pitches and stuff like that. There's a reason why people don't build that for SETI at home and folding at home. It's because if you want to build things at that scale, you have to borrow money based on future cash flows, which you don't have if it's voluntary. So scaling is something, capturing some of the value that you generate is really sort of necessary for very, very high scale. And then the other stuff, again, is, you run around the circles around Frontier Labs. Again, there's a hell of a lot more compute outside of Google than there is inside of Google. And so, in principle, you can crowdsource the compute, you crowdsource the human beings, which at least at the present time are a lot of value add. the Earth is much bigger in the amount of untrusted compute. So it's kind of inspiring to hear him say that. We don't think he'd ever heard of the Innovation Game. But then I sort of quote tweeted it, and this is my most successful tweet ever. I'm quite proud of this one. 3.2k likes, which is like more than 10 times more than I'd ever got for a tweet. And this is, I took quite a lot of effort to write what the Innovation Game is here. So if you look at it, it's quite a long thing. But anyway, that's just goes to show. We haven't heard from Andre yet, but a lot of people evidently appreciated it, which is why we got lots of likes. That's the end thing. But so basically that is a very quick whirlwind tour of their motivation for the Innovation Game and what it is. I realise it's a little bit offbeat, but as I said, the Richard Stallman example shows that sometimes it's worthwhile thinking about the bigger picture because we don't want things to go closed. Any questions?
Yeah, I'm curious about this licensing aspect. You mentioned that there was an incentive problem with it, but it sounds like I haven't heard much of dual license before, or like implemented in any domain actually.
Oh yeah, you haven't heard of dual licensing before?
Well, no, but I would assume that the problem with doing this open source plus closed source license, this is just naivety maybe on my part, would be similar to the issue you have with patents, because relatively. You can't patent like an entire procedure, right? You can't patent a general class of sort of complex functions. I've seen a few Google guys try to do it in some of their patents. But can you maybe expand upon how that works in practice?
Great question. It's a fantastic question. Yeah. So patents are an interesting thing. So this, just to say, was developed in partnership with another one of our co-founders, a guy called Philip David, who was the general counsel at Arm Holdings for 10 years. So he invented all the licensing around, working with Apple and so on. So he's a kind of like a big kind of open source and licensing guy. And patents are huge. And they're probably the biggest tech licensing company in the entire world. They're worth hundreds of billions of dollars, I think. Patents are a funny one, and they're not that much used, except for maybe defensively in open source historically. They're not that much used in the way that people think they are in tech as well. Normally they're used to build big patent portfolios so you can construct defensive coalitions to attack people who try and sue you first for freedom to operate. So it's not like you kind of invent something and then you license out the right to use it and get the money that way. At least in normal tech, it works that way in pharma, which again, a lot of people get confused with. They're absolutely sure that's the way patents work, but they only work that way in pharmaceuticals. So basically, the way they work, in traditional tech is what is the sort of value of the patent? What's considered a strong and a valuable patent? It will be one whereby, it kind of, the risk to the other party would be a credible threat of litigation, successful litigation, of course. So it's I don't want to, infringe that guy's thing because he might take me to court and his patent's quite strong, so it might win. The way that intellectual property in general, including patents, works in open source is a little bit different. So it's not credible threat of litigation; it's reputational risk. So people think that people are always free riding, kind of open source. It's actually not really true. Small guys do, big guys don't, because of the reputational risk. And it's also the community is quite sort of activist, they're quite intelligent, well informed, and it's also this kind of. I think someone called it paradox of vulnerability. It's a bit because everything's open, yeah, you could just take it and free ride it, but it's a little bit like guys stealing sweets out of a child, and that's a despicable crime, even for a criminal, right? You probably get shanked for that one in prison, because it's it's not, anybody can take it, right? So this is the reason why big companies they tend to respect the intellectual property rights of open source projects. And what you need for this kind of, community enforcement is, kind of really two things, a sort of feeling we're in the right, we're doing an open source project, that's kind of good, that helps in community cohesion, people sort of paying attention to what's going on, but also they want to feel sort of justified and empowered. They don't like mob rule. So if we also have the legal right, as well as their own perceived moral right, then it tends to work. And the property right gives them that. So it's a coordinator as to what it feels it's justified to threaten other people with reputational risk and all. And this is the key, because patents which cover algorithmic methods, there's a sort of dichotomy between broad and narrow. For certain reasons, people tend to have to go quite narrow. Otherwise, they're not seen as likely to prevail in litigation. But for the coordination purpose, it's different. You can go relatively broad on the spectrum of broad to, and people get the justifier, it covers that thing, and it will never go to litigation. So the kind of nuances of you know, whether it's likely to succeed or not in a court case are less relevant. So there are certain ways that open source projects can use IP, which closed source can't. No, you know, big groups of voluntary people go and, you know, enforce Apple's IP by reputational risk, do they? I mean, of course not. It only works for open projects. Open projects typically have not been able to utilize patents specifically. One of the reasons is because you have to divulge it before you file, and you don't know whether the open source project's going to take off or not, so you're not going to spend all the money on prosecution. There's like a chicken and egg. We have a revenue stream, so we can file patents, and we can afford to, and then we can rely upon community enforcement rather than. This is pretty technical, but it works, and Phil tells me it should work as well. But it's an excellent question because it's so counterintuitive when you say that, because there's so many people who are like, yeah, I don't file patents and I don't do it for a reason. And big tech companies file patents, but they don't do it for this reason. They do it for that defensive thing as well. So it's like, what are you talking about, John? This doesn't work. Actually, we think it does. Yeah, but great question. Anybody else? Yeah, thank you very much.